Hello Huskies, it's your favorite thing, story problems. We're going to practice writing some more systems of equations based on some story problems. I tried to find some interesting problems. For example, this is a true story, I'm not making this up. We saved up and took our family to Harry Potter World a few years ago. There's 7 people in my family. We wanted to try their butterbeer. There's no alcohol in it. It's just kind of like a butterscotch flavored soda. And they also sell a frozen version of it, kind of like a butterscotch Slurpee. It's delicious. So I bought 7 drinks at Harry Potter World. Some were frozen and some were regular. And I spent $41.50 all total. And then the story says that there were the frozen ones cost $1 more than the regular ones, and that the regular ones cost $5.50. So when you define your variables on this one, it's very important, as always, to use more than one word when you define them. X is going to be for me the number of regular butterbeers that I bought, and Y is going to be the number of frozen butterbeers that I bought. We already know the price. That is not what we're trying to find. We're just trying to figure out how many of each did I buy. Now, I know since there's only 7 total, you could probably guess and check this one all day and come up with the answer, but that's not the point, is it? The point is to try and learn how to write a system of equations so that you can solve it. So, I bought 7 drinks total. Some were frozen and some were regular. I don't know how many of each there were, but I know that the number of regular plus the number of frozen must equal 7. And this is one of those systems where we're going to have one equation that represents how many, the quantity. That's an A. Now, we also know something about how much each one cost, a value. So this is kind of like the coin problems also that you might see. We are now going to put a value on this. How much was each regular butterbeer? Well, it was $5.50. So if I multiply 5.5 times however many I bought, that would give me like the total amount that I spent just on the regular butterbeers. And then if I multiply the number of frozen times 6.5, that would be how much I spent on just the frozen butterbeer Slurpees. And all in total, I spent $41.50. It was the most ridiculous amount of money on drinks that I have ever spent. But there is my system of equations. Now, you could solve that one by elimination because everything is kind of lined up nicely. You maybe could multiply the top equation by negative 5.5 to eliminate the x's, or you could multiply it by negative 6.5 to eliminate the y's. I'm going to give you one more option here. By the way, I'm not going to solve any of these problems for you completely beginning to end. I'm just going to set them up and let you go. So one other option is that you could take this equation right here and you could subtract something from both sides. Like let's subtract y from both sides. Just for fun, you could have done this with x also. And so x is going to equal 7 minus y, because 7 minus y is just a trick question. It's 7 minus y. And then now you have isolated a variable. X is by itself. So you would take this 7 minus y, and you would replace x with 7 minus y. Don't forget to keep it in parentheses so you could distribute the 5.5. And that would be an alternate way to solve this problem. Okay, good luck with that. Next, we had this little Coinstar video in class. If you're watching this and you weren't in class today, then you didn't get to see the video, so you'll have to take my word for it. We have 1,400 coins total. There are only quarters and pennies in this pile of money, and the coins are all worth $62. So this actually reminds me of the Harry Potter problem we just did. Can you see the similarities? Well, this time, we are still trying to find out how many quarters and how many pennies, just like how many type of each drink did we buy. And we have an equation that could tell us how many total. Okay? Try to write an equation that would describe how many coins we have. Well, how many quarters were there? I don't know, but we called that X. How many pennies were there? I don't know, but we called that Y. And I do know that all together, if I add them up, I add 1,400 total. coins. That's my how many equation. Now let's put some value on it. Well, what's the value of a quarter? We could write that two different ways. One way we could write it is like this, and that would be like in a dollar format. And the other way we could write it is like this, and that would be in the cents format. It doesn't matter which way you choose, but you have to make sure everything is in the same format. And so up here when I look, I see that the coins are worth $62, and that's written in a dollar format. So I'm going to keep mine as the dollar format for my value of a quarter. But if you wanted to, you could totally change that into 6,200 cents and then just write everything without a decimal. That'd be totally fine. Well, I'm going to do it as dollars. And so I have X amount of quarters, but each one is worth 25 cents, written like a dollar, looks like that with a decimal. So if I multiply 0.25 times how many quarters I have, that would be how much money I have just in quarters. My family used to own a laundromat, and we would get together on Friday nights and dump all the money on the table, and we would have to sort the coins and count the coins. And so somebody was always in charge of counting the quarters, and someone else had to do the dimes, and someone else had to do the nickels. It might sound cool, but it was really disgusting. Your hands just got filthy black by the end. But anyway, if you were the person in charge of counting the quarters, you would count up how many you had, you would multiply by 0.25, and that would be how much money there was just in the quarters. Okay, how much money was there just in the pennies? Well, a penny is worth 1/100th of a dollar. That's what that looks like, 0.01. And if I multiply by how many pennies I had, that would be how much all the pennies were worth. Now together, all the money that we had was $62. So that's kind of like the value equation. I did a how many and then a how much sort of an idea. And there again is a system of equations you could solve by substitution or elimination. And so an easy thing to do might be to multiply this entire thing by negative 0.01 and then add down. So you could be like negative 0.01, negative 0.01, negative 0.01. Don't forget to multiply even the 1400 and keep going and add that to this equation and you will eliminate the y's. Okay, good luck with that. Next, I love these Oreo problems. A few summers ago, I spent the entire summer literally dissecting Oreos. I proved that double stuffed Oreos do have exactly twice as much filling. I proved it by calories, by height, and by volume. So yes, you can believe it when they say double stuffed Oreos, they do have twice as much filling. And the cookie part is just the same. So sorry. If I have 3 regular Oreos in a stack, that would be 160 calories. If I have 2 double stuffed Oreos in a stack, that would be 140 calories. So I'm wondering, if I scraped all the filling out and made a pile of it, which would have more calories, just the filling or the wafers? So the way I set this up, I said that the calories, the number of calories in one cookie, sorry there, I had to take a little break. Okay, I'm back. X is the number of calories in one regular filling, like I've scraped it out of the cookie, and Y is the number of calories in just one wafer, and there would be 2 in each cookie. So let's write an equation for the regular Oreos. What would that look like? Well, 3 regular Oreo cookies are going to have 3 regular fillings, and then we would have how many wafers? Well, we would have 6 wafers in 3 regular Oreo cookies. Does that make sense? So I would multiply 3 times however many regular fillings I have, plus 6 times however many wafers I have, and that would give me 160 calories. Oh, sorry, 6 is the number of wafers. Y is the number of calories in one wafer. Oh, phone. Okay, so then for the double stuffed Oreos, I only have 2 of those cookies. That means that I have twice as many fillings. So it'd be like I have 4 regular amounts of filling. Does that make sense? They're double stuffed. So it's like I took 2 regular fillings and smushed them together to make a double stuffed cookie. So that's going to be 4 times the amount of calories in a regular filling, plus just 4 wafers for these double stuffed cookies because I only have 2 cookies. And that is 140 calories. And that is my system of equations to solve. I highly suggest solving this one by elimination. Maybe multiply the top row by -4 and the bottom row by either negative or +3 or +6, or you could do the top row by +4 and the bottom row by -6. It doesn't matter which of those choices you do, but good luck solving it. By the way, you're going to get a decimal answer for those, because this is a real life problem. This is true. If you looked on the back of the Oreos, you could see that I'm not lying about any of these calorie amounts. And so, you could just, let's round off to the nearest tenth probably, because a tenth of a calorie is really a small thing. So you could round to the nearest tenth. Okay, next problem from the classwork. By the way, if you're here just for homework help and you were actually in class today, you could always fast forward to the homework at the end. I'm not going to solve them all the way, but I help you set them all up. So that's kind of my plan today, is just to give you more practice with these writing systems. Okay, so a mega mug. We already did the popcorn bucket. Now this is the same idea, but we're talking about a mega mug. And when you go to this particular movie theater, you can buy this plastic cup for $15.25, and then every time you fill it up, it's $1.75, and yeah, it's empty when you buy it. But if you just bought a regular medium drink, like in a cardboard cup, it would hold the same amount as a mega mug, and it only costs $5. So I'm wondering, how many times do you need to go to the movies and fill up a mega mug to make it worth your while to buy the mega mug? Now, one thing that's cool about the mega mug is you can use it year after year. That popcorn bucket expires at the end of the year, but the mega mug is good forever. So I kind of think you should probably just buy one. But, I don't work for the Megaplex. I'm not selling you anything. Let's figure out exactly what system of equations we could solve to see. Maybe you're just visiting from out of town and you just want to go to a couple of movies with your cousins. Should you buy a mega mug? Let's find out. I set this up to be that X is the number of drinks you buy, and then Y will be the total cost of drinks. And we're going to have one equation for the cardboard cup and one equation for the mega mug. So let's do the cardboard cup first. I think that would be a little bit simpler. So the cardboard cup, it's $5 every time you buy a drink. You buy 1 drink, it's $5. 2 drinks is $10. 3 drinks is $15. What am I doing there? I am multiplying. And what am I finding? I'm finding the total cost. So the Y would equal $5 times how many drinks I bought in the cardboard cup. Oh, that's a pretty simple equation. Let's write one now for the mega mug. What happens? Well, the total cost on the mega mug is going to be, well, first off, you have to lay down the $15.25. And then after that, every time you buy a drink, it's $1.75. So that's what you're multiplying by X. So there we have our system of equations. And since there's an isolated variable, boom, there, or even there, you could definitely solve this one by substitution. I would say, hey, if Y equals all that stuff, I'm going to replace Y with all that stuff. Subtract $1.75x from both sides, and you're on your way. You might need to round off again, but remember, we want to know how many times you need to buy drinks with the mega mug to make it worth your buying the plastic cup. So you should probably round up no matter what. Oh, I guess I had this all worked out so that I could show you how to do it, but I already did, so I'm skipping this page. Okay, last Oreo problem. This time we're talking about the thickness. We are measuring with a very precise ruler, and we have a stack of 11 original Oreos. It's 130 millimeters tall. Then we notice that if you stack 9 double stuffs, it's also exactly 130 millimeters tall. So that's interesting. We want to know, well, then, how thick is a wafer and how thick is regular filling? Could we figure that out? Well, let's just talk about the stack of originals. So imagine a stack of 11 Oreo cookies. How many wafers are in this stack? Well, there's 22 wafers in that stack. How many layers of original thickness filling are in this stack? Well, 11. 22 wafers. Am I just completely, sorry, not making sense? There's 22 cookies. There's 11 fillings. Yeah, 22 wafers, 11 fillings. Okay, I'm with it. I've got this. Let's use our variable. Let's say that how thick is a wafer is our x. And how thick is the regular filling? Let's call that y. That's what we're trying to find. That's what the question says. So we're going to assign those variables to be those things. So if in my original Oreo stack I have 22 wafers, then 22 times how many wafers, times how thick my wafers are, plus 11 times how thick my fillings are is going to equal 130 millimeters tall. Okay, now let's see if I can describe the double stuff stack without saying the wrong thing. I have 9 double stuff Oreos in a pile, in a stack. That means I have 18 wafers, and they are just as thick. They're just the same as the regular wafers. So I have 18 of those. Now I would have 9 thicknesses of double stuff filling because I have 9 cookies, but each of those are twice as much as a regular. So I don't really have 9 layers of filling. I really have 18 layers. And I don't know how thick they are. That's what my y is. But they also end up being 130 centimeters tall. Okay. This looks like you could maybe solve it by elimination. Here's my system. Multiply the top row by something, multiply the bottom row by something else. I don't know, if this was me, I would probably go times this by 18 and this by negative 11. That's just kind of how I see it. There are other ways to solve this one. I'm not going to finish it for you. Good luck with that. Okay, on your homework. Like I said, I'm not going to solve these. I am going to help you practice writing the systems, and then if you need help solving them, you can go back and watch a video on substitution or elimination. Okay, so I have a rectangle. Dun, 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 dun. This is my length, and this is my width. And so I'm going to say L is my length, and I noticed that I used a capital L so that I didn't get that confused with a 1. Sometimes I also use a cursive L. W is my width. Okay, so what would an equation be? Let's go back and read this problem. The perimeter of a rectangular rug is 42 feet. Perimeter means you go around and you add up all the sides. So that would be the length plus the width plus the length plus the width. And when I add up all the sides, I'm going to end up with 42. Well, I could simplify that a bit. Instead of L plus W plus L plus W, I could say 2 times the length plus 2 times the width equals 42. So I'm going to use that one instead. Okay, there's one equation. That's about the perimeter. Now let's go back to our problem. The length is 3 feet more than the width. The length is 3 feet more than the width. Which one is longer? The length is. Not just because that's length, you know, L is for longer. No, it's because it says the length is 3 feet more than the width. Okay, so that is my second equation that I could write. The length is 3 feet more than the width. Hey, looky there. I have an isolated variable. L equals all that stuff. I'm going to replace L with all that stuff. So I get 2 times 3 plus W plus 2W equals 42. That is my equation that I'm going to solve by substitution, and I'm going to let you finish that. Okay, Jack is selling tickets to a fall musical. On the first day of the ticket sales, the school sold 4 senior tickets and 7 child tickets for a total of $133. The school took in $73 on the second day by selling 4 senior citizen tickets and 3 child tickets. Now we want to figure out how much are these senior citizens paying and what does it cost for a child to go. So I'm going to say that X is the price or the cost of a senior ticket. And remember, I want more than one word when you define your variables so you can help keep track. Are you finding the cost or are you finding how many? Sometimes it's confusing, and so if you start off by making sense of this problem and first of all realizing that you're trying to find a price, not how many, but how much they cost, that's going to help you. Okay, let's write a system for this. Well, I don't know how much senior tickets cost. That's what X stands for. But I know on the first day I sold 4 of them. So that would sound like 4X. And I don't know how much a child's ticket costs, but I know on the first day I sold 7 of them. And all total we made $133. So that's kind of like day 1 equation. Now we're going to have a day 2 equation. So on day 2, what happened? Well, we made $73, it says. We sold 4 senior citizen tickets and 3 child tickets. Hey, that looks really simple to solve by addition / elimination / combinations. And I'm going to leave you to it. Okay, 2 angles are complementary, and then I even give you a little hint that says, remember, the measures of complementary angles add up to 90 degrees. Okay, so, if X is an angle and Y is the measures of my angle, my other angle, X and Y are the measures of angles. Okay, I've defined my variables. I'm looking for 2 angles, their measures. Well, I know they're complementary. Right there, that's an equation. I know that the sum of the measures of these angles is 90 because complementary means the measures of the angles add up to 90. Well, what else do I know? I know that one angle, which one? I don't know. Doesn't matter. One of them is 42 more. 42 more. So one of the angles, let's just pick X. One of the angles, X, is, that's equals 42 more than half of the other. 42 more than half of the measure of the other angle. Okay? Hey, look. I have a system of equations. I have an isolated variable. I can solve that thing and figure out the measures of both angles. Remember, you're trying to find out 2 angles who add up to 90 based on this set of criteria. So solve that one by substitution, and good luck. Morgan and Dylan are doing some yard work. They bought their supplies. Morgan spent $42 on 3 rose bushes and 3 shrubs. Dylan spent $54 on 7 rose bushes and 3 shrubs. What are the costs of 1 rose bush and the cost of 1 shrub? Hey, that's what we're trying to find here. My variables could be then that X is the cost of a rose bush and Y is going to be the cost of a shrub. We already know how many they bought. We want to know how much they cost. So Morgan, we're going to have one equation that represents Morgan and one equation that represents Dylan. So Morgan spent $42. She bought 3 rose bushes. How much was each rose bush? I don't know. That was what we called X, but she bought 3 of them. She also bought 3 shrubs, and we don't know how much the shrubs cost, so we called that Y. And she spent $42. Now Dylan spent $54. He obviously bought more. He spent $54 on 7 rose bushes and 3 shrubs. Hey, when you write it out like that, I hope you can see how simple that will be to solve by elimination. Good luck with that. Savannah spent $131 on shirts and jeans. This time, it's a little different than the roses and the shrubs because we don't know how many of each kind she bought. She just threw some clothes on the counter. She spent $131. But we know that all the jeans in that store cost $28 and all the shirts in that store cost $15. And she bought 7 things. Okay, she just piled 7 items of clothing onto the counter. So let's see. Does it remind you of a coin problem or the Harry Potter problem? She bought a total of 7 items. Remember the Harry Potter drinks from the classwork? I bought 7 drinks. So I'm going to have one equation that's how many. And then I'm going to put value on it. So that's what my 2 equations are going to look like. Let's define our variables. I'm going to say that X is the number of shirts that she bought. Don't just say S is for shirts. Is that how many that she bought or how much they cost? You have to make sense of this problem. It's how many, the number of shirts and the number of jeans. Okay, how many shirts did she buy? I don't know. That's why we called it X. How many jeans did she buy? I don't know. We called it Y. But how many did she buy altogether? 7. She bought 7 altogether. So the number of shirts plus the number of jeans equals 7. That's my how many equation. Now let's put a value on it. We know that she spent $131. And we also know that each pair of jeans was $28 and each shirt was $15. How much did she spend only on shirts? Well, I don't know how many she bought, so how am I supposed to know that? Well, let's write an expression. It would be $15 times however many shirts she bought, which was X. And the jeans are going to be $28 times however many jeans she buys, which is Y. Okay. Hey, there's a system of equations to solve, either by substitution or elimination. You could isolate a variable in that top equation and then plug it in, or you could multiply the top equation by a value and add it to the second one to eliminate. I'm not going to go any farther, but I know you can do it. Last one. A class of 195 students went on a field trip. They took 7 vehicles. Some were cars and some were buses. Find the number of cars and the number of buses they took. Hey, 7 again. Does this remind you of something? It reminds me of Savannah buying clothes. It reminds me of when I went to the Harry Potter world because we have 7 vehicles. Some are cars and some are buses. So again, I have this how many. And they add up to 7. So maybe it says find the number of cars and the number of buses. So I'm going to say that X is my number of cars and Y is my number of buses. Because when I went back and read the problem, that's what it's asking me to find. So it's a pretty good guess that those are my variables. How many total vehicles did they take? 7. How many were cars? I don't know. We called that X. How many were buses? I don't know. We called that Y. But all together there were 7 of them. How many? That's my how many equation. And again, wow, look at that. Exactly the same as Savannah. And I could go all the way back to show you the Harry Potter one, the same thing. So you can see that I'm not really even changing the process. I'm changing the words, but a lot of these are kind of parallel problems. Now let's put a value on each one. Well, there's no money involved in this problem. What do you mean, Mrs. Bagley? What's the value? Well, how valuable is a car? Each car could hold 5 students. So the value of each car is how many people could ride in the cars. That would be 5 times however many cars there were. Hey, each bus, that's pretty valuable. Each bus holds 45 students. How many buses did I take? Y. I don't know how many, but I called it Y. So 45 times Y is going to represent all the kids that rode in the buses. How many kids went all together? 195. So there you go. I put my value on, and now I have a system of equations to solve, either by substitution or by elimination. Alrighty then, good luck with that. We got you out of here in under 30 minutes. I hope you can finish your homework. It's pretty simple from here on.